Welcome guys in this new tutorial of Blender and Geometry Nodes. In this video I want to show you how to make a very reliable and flexible rotation node for your meshes. The basic idea is to take something and rotate from an A direction to a B direction with many features added to this goal. You will discover very useful utilities inside your project to align the rotation of some elements of a source geometry to some elements of other geometries, delay animation, fixed rotation, and so on. So let's get started. I'm working now in Blender version 4.5.0, the new version released, and what we want is to take something and rotate pointing from a starting vector direction to a final vector direction. So to start with this idea, I made a simple plane. I go in edit mode, I rotate on the y-axis by 40 degrees and then around the z-axis by minus 20 degrees. Okay, like this. The object has no rotation, and now imagine you want to rotate this mesh from the vector of the normal of this face, from the direction of the normal of this face along the y direction. So I want to have a rotation from A to B, and to do this operation what we need is to take the normal as the source direction, the y-axis as the target direction, and to make a rotation between this vector and the other vector we need an axis of rotation. So an axis that needs to be perpendicular to the plane created by the source and the target vectors. To see better this result, I'm going to add a simple material here. I enable the preview material and I link in this base color an image texture, creating a new image and selecting here the color grid and pressing new image. And we have the image on our plane. Now we need to draw the normal of this face. So I'm going to go in the plus button, General, Geometry Nodes, and press New. And to get the normal of this face, I can use the sample index because I want to get the vector of the face of index 0 because this plane has only one plane. I link the geometry, I get the normal field of this face, and now with this output I can create a curve line starting from 0 and ending to this normal. I can join these together and now you can see the direction of the normal of this face. Now to rotate this object from this vector to this vector, that is the target we want to reach, we need the plane between these two vectors and make an axis of rotation perpendicular to this plane and rotate this vector by the degrees between these two vectors. So two main ideas: to get the angle between two vectors, we can use the dot product formula. So the dot product is the multiplication between the module of an A vector multiplied by the module of the B vector multiplied by the cosine of the alpha. This is the most important part. So we need to normalize these two vectors to get only one unit, so one length of the vector, because what we need is only this part of the formula, that is a value that can be between 1 and minus 1 depending on the alpha degree between these two vectors. And the cosine of the alpha, I remember you, is the segment, the horizontal segment given by the projection of the A to the vector B, that is this in this case with a radius of 1. So this is the cosine value of this alpha. This means that if we have two parallel vectors, we have 0 degrees and cosine of 0 equal 1. So the entire segment between here and here, okay, because the projection has the same length. But if I increase the degrees to 90 degrees, for example, so perpendicular vectors, here we have 90 degrees and the cosine of the 90 degrees is equal to 0 because the projection of this segment on this horizontal line, okay, has a length here very little, so equal to 0 in this case. From this cosine of the alpha, to get the angle, we need to apply the arccosine, so the opposite, the inverted function of the cosine, and the arccosine, the alpha, can give me alpha itself in radiant. Remember, in Blender, this operation can give you radians. So the steps are: 1. Normalize A and B to have 1 for the length of both of these vectors. 2. Apply the dot product from A and B. And 3. Apply the arc cosine of the dot product. And we have this alpha. But what about the axis of the rotation on which we want to rotate the object from A to B? So the axis needs to be perpendicular to the plane between these two vectors. And to create this vector, we can use the cross product. So the cross product, if I have an input A and an input B, can give me a perpendicular vector in the 3D space, and depending on the order of A and B, can give me a one direction or the opposite direction of the final vector. So if you want to know more about the cross product, I will leave the link of another video here and in the description of this video tutorial, so we can go further. And what I need to know is that the cross product is equal to the same basic idea of the dot product, but instead of using the cosine of the alpha, we have the sine of the alpha. And this can give me the length of the perpendicular vector, but you need to know that the output is a vector and not a single value, a scalar value, as the dot product. So in our geometry nodes, we can make a new group node. We can use the set position node, that is the main node we need to use to rotate each of these elements, rotating them by a certain angle. So we can take this set position and press Ctrl G to make a group, and we can delete the position and the offset, and we can leave the selection because maybe you want to rotate only some elements of this geometry and not all the elements. I enable the snap tool here, and I'm going to add a new vector as the from, and a new vector that is a subtype X, Y, and Z. I will leave the structure type to auto and not single, because you will be able to assign a different from vector or a different to direction vector for each of these elements if you want to. So this is a very powerful feature. The same from this socket 2, that is a vector subtype X, Y, and Z. And this is the final group node. Okay, we can rename this set position to rotate 2. Now we need to calculate what we discussed previously. So we can go inside the group node, take the from, and calculate the dot product between this from and the to vector. But before this operation, you remember the first step: normalize these vectors to have the correct length multiplied by the cosine of the alpha. So because I don't know what input vector the user can assign here in this input, for security reason I add here a normalized vector, H to collapse, Shift D to duplicate, and now I can do the dot product from this dot product. So from here I have 1 multiplied by 1 multiplied by cosine of the alpha, so this is equal to a cosine of the alpha. I can execute the arc cosine the alpha, and here we have the radians of the angle between the first vector and the second vector. Now we need the cross product to get the perpendicular axis of the plane made by these two vectors, the from and the to, and I can drag this normalized to a cross product, H to collapse, link the other, and from this output I have the axis of the rotation. Now what we can do is to take the actual position of each element and add a rotate vector or vector rotate node that has an input as the vector to rotate. In this case, each point has the own vector position, always starting from the origin point of the object, and we want to use an axis and an angle of rotation, and I can link the cross product as the axis of the rotation and the arc cosine for the angle of the rotation. Next, I can link this output in the position, and the basic idea is this. So if I exit from this group node and assign for the from the vector of the normal, because I want to rotate this geometry from this direction to the direction of this y-axis, I can get the normal of my face and link this in the from, and in the two direction I can easily set one in the y direction. And as you can see, we have the correct rotation of our face through the positive y-axis. We can extend this group node adding inside what a factor that we can call factor like this from 0 to 1, and this is a factor value, leaving the structure type as the auto. And next we are going to see the delay effect of the rotation of some elements as an example. And what we can do is to move this a little bit and multiply this factor by this arc sine. So in this way, if the factor is 0, the resulting angle of rotation will be 0. If the factor is 1, the angle of rotation will be the total amount of radians from this output. And now if I exit from this, and as you remember, we have the face like this, and the positive axis of the y is this, so I will change this vector to -1 because I want to go from this direction to this direction, so the negative direction of the y-axis. And if I increase the factor, as you can see, we have the correct rotation, and you can see the perfect alignment through the plane between these two vectors. Indeed, if I increase this factor, you can see a line, a perfect line, rotating on the plane between these two vectors, the from and the to vector of this node. Now we can extend more this group node, adding what? The center of the rotation, because maybe I don't want to rotate this object from the center of the object, but from another point of the 3D space, another pivot of the rotation. So I can go inside and duplicate, for example, the 2 vector, rename it in center, and also in this case we have the subtype x, y, and z, and we can link directly the center inside this center vector rotate. In this way, if I want to change the center of the rotation, for example, from this point, okay, the -2 in the y-axis, I can set -2 in the y-axis, so this point. And now if I increase this factor, you can see the rotation is starting from this point here, as you can see in this way. Now I reset for a moment the center, and what if I want to rotate not using the minimum angle between these two vectors, but the opposite angle? So imagine you want to rotate not from here to here, but in the opposite direction. If you want to do this operation, it's very easy to do, because if this is alpha and the entire round is equal to 360 degrees or 2 multiply pi radians, because we are talking about radians and not degrees inside this group node and in general inside the geometry nodes in Blender. To have the opposite value of the angle, we can do this operation, 2 multiplied by pi, so the total round minus alpha, and we have the opposite value of the angle. And we can multiply this value by -1 because we want to rotate not in one direction on the axis of the rotation, but in the opposite direction. And to do this, we can go inside this group node, take this arc sine, and apply a little mathematical operation. So I can subtract from 2 multiplied pi, so the entire round, this alpha, and multiply this value by -1 to go to the opposite direction of rotation. So in this case, we need to add another input attribute we can call flip rotation, and this is a Boolean flag. We can add the group input inside our workflow and ask us if the flip rotation is true, and if it is true, we want this output, so the opposite angle we want to use for the rotation. Otherwise, we want to maintain the correct output of the arccosine, so the minimum angle of rotation between these two vectors, and use this output in the multiply with the factor to have more or less influence of this rotation on our mesh. We can move this node a little bit, Ctrl H to collapse this, I collapse this switch, move this multiply, the position and the set position. Now we can test it. If I go out from this and move the factor in this way, we have this kind of rotation. But if I flip the rotation and increase this factor, you can see the exact opposite behavior, because maybe you want to have the flipped behavior. Now we can do better, because we can use not only this factor to have the minimum angle of rotation or the opposite direction for the rotation, but maybe we want to have a free rotation, always using the same axis of rotation we calculated inside this workflow. So I can add another attribute duplicating this flip rotation, and I can rename it in free rotation and add a new attribute as the rotation. This can be a subtype of angle to better understand the value I want to input inside. I can add another time the group input and ask me if the free rotation is true. So if the rotation is true, what I want is the free rotation input of my group input. Otherwise, I want to use the factor or the flip rotation. I can press Ctrl H to collapse this switch. I need to move this multiplication here in the false condition, because here I want to use the output of the multiplication between the factor and the angle before going here in this switch, and use this as the final angle for my rotation. In this way we can test it, so I can check the free rotation and start to rotate whatever I want, and for example assign a scene time elements linking the seconds inside the rotation. So in this way I can press play and see the object rotate using the correct axis of rotation. As you can see, ad libitum, I drop this connection and they check the flip and the free rotation. Now what I can do is to move this cross product a little bit and make some frame. So you need to know that in the Blender version 4.5.0, the making of the frame is no longer the Ctrl J for the default shortcut, but the simple F key. So I can move this a little bit, and if I take this node and press F, the system is going to create the frame and automatically open the node label input to set what you want to write. So in this case, rotation axis. The same I can do for this entire group of nodes, frame with F and angle rotation. Now if I exit from this group node, you can see the easy way to use this node. For example, if I want to move from the normal to the Z axis, I can set here 1 to the destination vector direction and increase this factor, for example. So the idea of this group node is similar to the align Euler to vector, now deprecated from Blender, or the actual line rotation to vector, the new one. So instead of using an actual rotation, forcing the X, the Y and the Z axis, we don't need to force anything, because we only want to rotate the object from a vector direction to another vector direction using the minimum angle of rotation the system can calculate. So we calculated. Okay, very useful, but if we want to rotate this mesh not using a vector but using the vertex group information. So imagine you want to rotate this mesh, rotating itself from this point in this direction to go in the same direction of this edge here. So the vector between this vertex and this vertex. Okay, imagine this. From this vertex and this vertex, I want to have the target direction, and I want to start from, for example, this vector of rotation made by the vector between this vertex and this vertex. So to do this operation, we can use the vertex group of the mesh and calculate this target and source, so the from vector and the to vector, and calculate the center of the rotation to rotate this mesh. How do this? So it's not hard, because we can go in the edit mode of this mesh, take these two vertices, press plus in the vertex group, set here the 2, because this is the target direction I want, so this is the vector of the final direction, and assign these two vertices. The same for the source, so the starting of the rotation, okay, because I want to rotate this object starting from this direction and finally through this direction here. So we can add a new vertex group and call it from and assign, and then a third vertex group we can call the center, and because I want to rotate from this point, I can assign this vertex. In this way we can make this group node without knowing always the number of the index or indices of the vertices inside our mesh to calculate the direction from and to, but we only need to assign these vertices to the correct vertex group. In this way I can go inside my group node and I can add what? I can add a from socket that is a string value, because I want to write the name of the vertex group to get the correct vertices and calculate the vector for the from, and the same for the to. So I'm going to duplicate these, move here, set to, duplicate another time, rename it in center and move it down, and now I can add a group input here and calculate the correct vector of the from using these two vertices. So to do this we can take the entire mesh and use the sample index node twice to get the position of this vertex, the position of this vertex, and because we know that the sum of two vectors is equal to the third vector, we can do a subtraction. So if we want to go, for example, from A to B, we can take B and subtract A, and what we have is this vector result. Okay, as you can see, this plus this vector is equal to this vector, and this vector here is the direction we want to use for the from. So this is why I need to use 2 times the sample index, because I want to get the vector for the index 0, but not for the entire geometry, because we can have multiple vertices of our geometry. So what we need is to filter all the vertices inside the vertex group set here, and to do this we need to separate the geometry to get only the points that stay inside this vertex group. So from this we can use the name attribute and ask if this attribute of the vertex, the weight of this vertex group is equal to 1 for our vertices. And this means that if I go in the edit mode and, for example, select this vertex, you can see here the weight, so the values set for the vertex group in which the vertex stays. So in this case, if I deselect all the vertices and go to from and click select, this vertex and this vertex will have the weight of 1 in this vertex group. So in this case I need to ask if the attribute of this named input attribute is equal to 1 and select only these two elements. In fact, if I press Ctrl Shift and click, you will have only this vertex and this vertex. How? Going out from this group node and setting here the name of the vertex group, so from, okay, and if I go inside and enable the viewer, you can see this edge made by these two vertices. From this separated geometry we only have two vertices, so the first with the index 0 and a second with the index of 1. So I can easily set here 0 and 1 and get the position of both of these points and subtract one from the other to get what? The different vector between these two vector positions. And doing this I have have the final from vector we need to use inside our group node. But what we need is to have another input attribute to decide what kind of from method we want to use inside our group node. So the vector method or the calculated vector method using the vertex group of the geometry. So to do this, we can add here after the selection a new input. This is a new menu, and we can link this from in a menu switch, and we can duplicate this group node to link directly here. This change the vector we want to have in the output to normalize. So you can see here we have the from as a vector input, and here we have the vector calculated by the vertex group. So we need to select this menu switch, go in the node section and change the name of the items inside this menu. So the from vector and from vertex group. So in this way I can link the from here and from vertex group here and use these to normalize and to make the dot product, cross product, etc. So instead of using this from, I can use this from here and press Ctrl H and move this a little bit here. Now I can press Ctrl H and collapse this node, select all these group nodes, press F and from as the name of the frame, and at the same time we can do the same for the to vector of the direction, easily selecting all these frame and pressing Shift D. I can rename these in to, and as you can see we have a new icon for the warning. Use node groups to reuse the same menu multiple times, but we don't need to use group nodes to reuse this menu switch because we need to use another menu switch for the to vector and to vertex group. So I'm going to go in the group section and duplicate these from, rename it in to, move this a little bit down, Ctrl H to expand this group node and link the to menu in this to menu, and the warning is gone. Ctrl H. Now we need to link the direct to vector, select the menu switch, go in the node and rename these two attributes in to vector and the to vertex group. Ctrl H to collapse, and this is correct, the to vertex group, but here in the group input we need to expand this and link the name of the vertex group for the to direction. Ctrl H to collapse. This is the same part, okay, it's correct, and then link this output of the to, where here in the normalized node, because we want to calculate the dot product and the cross product to have the correct rotation axis and the angle of the rotation. So we can link this normal here, and as you can see we can take this group node, Ctrl H, and move this a little bit here. We can move this node a little bit, is more clear, and we can select this from and this to and move this here like this, and now we have the correct section. We can exit from this group node and we can test it. Oh, okay, we forgot to set a default type of method, so we can go inside, go in the group node, and we can select the from and select for the default the use of the from vector, the same for the to vector. I forgot to link the same separate geometry also in this sample index, and the same here, otherwise we can't calculate the correct vector for our purpose. And now I can select the to vector, and we already assign a from, as you remember, for the normal. And now I'm going to hide the annotation, exit from the edit mode, and now we can test it, because if I create a little UV sphere and move one here and one here with the Shift D to duplicate it, and Shift D another time to have another here, okay, you can see these three spheres. We can select our object. We defined the correct vertex group, so we can go to the from vertex group from to the vertex group 2. Oh yes, we need to have the same for the center. So we need to go inside and another time duplicate this menu, duplicate, center, move these a little bit down, take for example this from zone, shift D to duplicate because we need to calculate the correct center of the rotation. And in this example we can do an interesting thing. Instead of using a single vertex for the center pivot, we can use the average of all the vertices inside the same vertex group. And next I'm going to show you a very useful case in which this can be very cool. So the same as before, we need to expand this group node and link what? Link the correct menu in the menu and the vector in the from vector, but not in this case the from vector. I need to select this menu switch, go to the node and rename it in center vector and the center vertex group. Now I can collapse this node and expand this and link not the from name string of the vertex group but the center. I can close this group node and instead of using the sample index here, I can use the attribute statistic node linking the separated geometry and get the vector, link the position of all these elements and take easily the mean, so the average of the position of all the elements inside this separated geometry. So I can drop this sample index, drop this, I can link the mean inside the center vertex group and drop this subtraction because we don't need it. Press Ctrl H to collapse this node. We can move a little bit this object and we must not normalize this vector because this is exactly the point of the center of the rotation. So a vector with a specific position in the 3D space. So I need to drop this normalize and rename it in the center. And now we can link this output in the center of the vector rotate node. We can drop this, move this group a little bit, and now we can test it. I go out, we have the from vertex group to vertex group using a center vertex group node called center. I forgot to link the correct selected separated geometry here. Okay, now it's correct because I want to have the selection and not the inverted selection. We can go out from our group node and we can test it. So if I increase these, you can see the correct rotation of the geometry along this path and this vector. Okay, starting from what? From this vector. So in this way I can take this vertex and move here, for example, and as you can see, if I increase this vector, you can see the behavior is always correct and follows the correct axis on the plane of the rotation. But maybe sometimes you have a problem, so you don't want to go through this direction, but you want to go in the opposite direction because the system cannot know what is the starting point and the end point of the direction you want to use for the target or the source direction. So for this reason we absolutely need to add inside our group node a flipped direction as a boolean. So we can add another input and call the flipped from, and this is a boolean. We can duplicate it for the flipped 2. We don't need a flipped vector for the center because the center is only one point, one position, one point in the space. So we can move this here, and now inside this from we can expand this node and ask if the flipped from switch is on, and in this way we can set an integer and duplicate this another time, because for this sample index we want to have the index 0 and the index 1 in one case, or the index 1 and the index 0 in the flipped version. So in the case we don't want to use the flipped version, we can set false and true and link this to this index and the opposite value for this sample index node. And where the flipped from is true, we are going to link the value of 1 here and the value of 0 here, so the opposite. And this will invert the result of this subtraction, so the inversion of the vector direction. We can press Ctrl H to collapse, create some reroute, and this is the from. For the two section the same, so we can take these two nodes, press Shift D and press Alt P to separate from the frame, G and click to go inside this frame, link this output inside this index and this inside this index, like this, expand this and ask if the flipped to is true or false in both of these switch node. Ctrl H to collapse, create a reroute and move this a little bit. We can make another reroute here. Okay, now if I want to rotate this object not in this direction but in this direction, because I want to go in the opposite direction of the target, we can easily flip the 2 and increase the factor, and as you can see we have the correct rotation of the mesh. Obvious, you can flip the rotation, so you can go in the other direction through the rest of the angle of rotation. Now let's add some warning for the user if it adds lots of vertices inside the to and from, and the system could calculate wrong vectors for the rotation. So here inside this group node we can take this selection, this separated geometry. I think it has only 2 vertices for the calculation of this vector, but we can go here and drag this output in a domain size node, asking if the point count of this mesh is greater than 2. So if I have more than 2 vertices, we can link this in a warning node, showing the warning and setting, for example, a message like this. So the from Vertex Group has more than 2 vertices, and this means that the system will continue to calculate the vector using only 2 indexes, so the first and the second vertex of the mesh. In the same way, we can take these and press Shift D and move these down for the from and link the selection of the separated geometry here and change the to Vertex Group has more than 2 vertices. In this way, if I go out from this group node and, for example, go in the edit mode and press Shift Z to see only the wireframe mode, and, for example, go in the from Vertex Group and press select, you can see only 2 vertices. But if I select these and click assign in the from and exit from the edit mode, you can see here the warning inside the header of the rotate to group node. So from Vertex Group has more than 2 vertices. This will allow the user to not set more than 2 vertices inside the Vertex Group used for this purpose. So I can go here, select these and remove from the from, and as you can see the warning has gone. Now let's talk about the instances. So imagine you have here instances. So this face is an object and this curve is another object. So for example, here we have the curve line, and I can convert this to a mesh using a circle curve like this. I can link this in the profile and set a radius of 0.1 and link this to geometry. I can decrease a little more like this. I hide the annotation, I hide the 3 spheres. These are 2 objects. So imagine instead of using this mesh you have instances. So I will transform these into an instance, so geometry to instance like this, and the same for the curve. So now from this join geometry, if I press Ctrl Shift and click, we have in the spreadsheet 2 instances, okay, and this output goes inside this rotate 2. It's obvious the rotate 2 group node cannot work in this case because I have no reference to the vertex group of these instances. So if I increase this factor, nothing works, and it's obvious. I will need to extract the information of the vertex group like we've done inside this zone, but out from this box, starting from this geometry, and then link the vector here inside the from vector and to vector to be able to work with this rotate to group node. But in this case, if I want to rotate these instances from a vector to another vector, I cannot use the vertex group, but only the vector. And in this case, if I use, for example, for the from, the normal of our face, the initial face, and to along the negative y-axis, so this direction here, okay, from this point to this point, this direction, nothing works. Why? Because inside this I'm using the set position, and the set position for instances has the initial position always to 0. And I can prove you, because if I exit from this group node and press Ctrl Shift and click to this geometry, you can see this instance that has the position of 0. So Blender, when you transform whatever object you want in an instance, applies and set a value of a position of the instances to the global origin point of the 3D space. So you lost whatever information you had before. And not only this, but you need to use another approach, so the using of the rotate instances. So this is the correct node you need to use for instances. This means that in this case we need a new attribute at the bottom of the group input, so another input called as instances, and this is a Boolean type, and in this case the structure type is single, so I want to have only one flag for this purpose, because I'm going to rotate only meshes or curves or instances, for example. And for the curves we are lucky, because the set position works also for the curves and the control points of the curve. But for the rotate instance we need to add another time here the group node and ask if we have instances. So if we have instances, the geometry we want to link to the group output is this. So in the case of as instances we need to have the rotate instances output, otherwise we want to use the set position like this. And not only this, I can press Ctrl H to collapse and move a little bit this node. We also need to calculate the correct rotation of these instances, passing what? The input geometry. So we want to use the input geometries as instances, so we hope they are instances. The selection, so in this way we can select only a particular number and selection of instances to rotate, and this is perfect for our goal. And use the center input for the pivot point, so in this way we can use the correct pivot point for the rotation. And last but not least, the calculation of the correct rotation. So for the rotation we can use a useful node to transform a rotation need between an axis and angle of rotation to a rotation output, okay, the quaternion conversion in the 3D space. So here we have the rotation axis and here we have the angle of the axis. So from here we can add this node axis angle to rotation, and we can use this as the axis, this as the angle, to have the final rotation inside our rotate instances node. And if I exit from this node, now we need to select not the center vertex group, because we are working with the instances, remember, but we need to take the center vector. Next, we are going to check the as instances, and we can increase this factor. And as you can see, we are moving and rotating these two objects and instances from the starting direction to the final direction. And at the same time, we can rotate these instances using a different center. So I can set the -2 in the y direction, so here for example, and if I take this sphere and move this here, you can see the correct rotation. So I set here the center of the rotation for these instances, and now if I increase this rotation you can see the correct behavior. And I can select only one of these instances, for example, adding the index and asking me if the index is equal to 0, for example, because I want to only rotate the first instance, and this is the result, or the second instance, and this is the result of the second, and so on. Now we can do a better job inside this rotate to group node, because inside we can use the same as instances switch also here in the from and the to section to help the user automatically use the correct input. So if I have the instances in the switch, we need to have these from directly inside our final switch if we have the as instances. So I press Ctrl H to collapse, and in the false condition I want to follow the way using the menus switch, so the vector method or the vertex group method. In this way I can link this output in the normalized and have the correct behavior, and the system will automatically connect the from vector input inside this flow if I have the as instances. Otherwise it will use the method I want to use for calculate or get the from vector. In this way, if I go out from this rotate to, you can see that we have the from vector read, and if I decheck here I can choose the method I want to use. And remember, if you have the from vertex group and check the as instances, the system will always use the from directly and will always show the two parameters for the from vertex group. You don't care, obviously. We can do the same for the to group, so we can take this and this switch, and we can also move this node a little bit like this. We can take this and this, duplicate with a Shift D, grab inside this group node, so Alt P and G and click with the mouse inside the section, move these a little bit up. We can link this to the normalize and this output in the false condition, but keep in mind here we don't need to use the from, but we need to use the to in the switch. Ctrl H and voila, this is correct. We can select all these nodes, G to move a little bit. Last thing related to this group node that we can select and colorize with the correct geometry color tag. So in this case, if I exit from this, you can see the correct color, because these can transform your geometry in some way. We can go inside this group node and enable modifier and tool. So in this way you can add directly this group node inside your modifier. So pressing this add modifier, go to unassign, and you can see you can directly add the rotation to inside of your stack. I'm also going to click with the right button on the name, right click and mark as asset. So in this way you can use this and drag from the asset browser inside whatever project you want. And finally, inside I want to add here a sort of rotation compensation. So imagine, for example, we have this mesh and we want to rotate this mesh from this normal to this axis. We already had this, so as you can see we can increase this factor from the normal to the -1 axis on 2. But what if I rotate this object 90 degrees on the X? As you can see, if I increase the factor, we have a wrong target direction. Why? Because the -1 is related to the local space of the object. So in that case, if you already have a rotation on your object and you want to maintain the same target in a correct way, we can do this. We can add the self object and link this in an object info node to get the actual rotation of the object itself. And if I take the target vector like this, so 0, -1 and 0, so this vector, I can rotate this vector by a rotation. And what rotation? The actual rotation but inverted, and use this vector for the target rotation vector. So this means that the system will take this vector, rotate this by the opposite rotation of the object itself, so in this case of minus 90 degrees on the x, before create the final vector and link these in the two input. And this is very important to maintain the correct target we need to use inside our node. In fact, if I now increase this factor, you have the correct behavior, the correct direction of the rotation, even if I take all these three axes and start to move in some way. Okay, this is very, very important. So if we want to compensate this in a free way, we can add another Boolean attribute inside our group node. So we can take this node here, press Ctrl C to copy, go inside the rotate 2, go in the 2 section, paste these nodes, and instead of using this target vector, we can use the already chosen vector like this and link this to the normalized. We can drop this node, collapse this, and we can move all these nodes a little bit, but we need a new attribute input at the bottom of this group node. So we can duplicate this and call comp object rotation, rotate to the 2 vector by object inverted rotation of object. We can add another time the group input inside our workflow and ask if this compensate is switched on, and here we can choose the vector, and if we don't have these two true, we can link this switch, otherwise this rotated vector, and link this to the normalized. Ctrl H to collapse, and voila. In this case we can drop these and drop these nodes, set -1 as the final destination, and if I take this object and increase by 90 degrees on the x and increase the factor, you can see the problem. Instead, if we check this compensation of the object rotation, we can increase and get the correct final rotation where we want. And this is the final rotate to group node. So let's make some examples. Okay, let's make a grid, and I will do this, Shift, Alt and click to see this grid, Shift Z to see these faces, and next we are going to use the split edge, and imagine you want to rotate these faces from the normal to the negative y direction, but with a delay. Okay, so not the same rotation at the same time for all these faces. So now that we split edge this mesh, we can duplicate this rotation and apply this rotation, and as you can see, if I set from the vector 1 on the z and -1 to the y, we need to use the correct center, as you can see, because if I increase the factor, we have the faces as a single object like before. So to have the correct center of each face, we can use the new node of Blender 4.5, so the average field that is evaluated in the context of the geometry, so no longer using the attribute statistics, and we can calculate what the average of the position of each face, and the group ID is the island index of each point. Okay, so each point has an island index. So for example, 1, 2, 3 and 4 has this index, 1, 2, 3, 4 has this index of the face connected, etc. So this field average can calculate the mean, so the average of the points grouped by this ID, and this means that I can use this as the center, and I need to link the position inside the value I want to use to make the average, and if I increase the factor, you can see all the faces as are rotating from the Z to the negative Y direction, but I want to have a delay from 0 to 1 for all these faces, and to have this delay we can use the sin attribute, so the seconds, and use the index of each element, but in this case I don't want to delay the single point, so the single vertex of the geometry, but I want to delay these elements based by the island index of each point, to be able to delay all the 4 vertices of this face together with the same delay. So we can use this island index, and you need to image to subtract, so to delay the seconds by the index of the island itself, to have time between the value 0 and 1 for this factor value for each face. So what does it mean? It means that if I take the seconds, and imagine you have the time like this, I have the time, the second 0, and I have the index of 0, 1 and 2. Okay, this is the time, and this in this direction is the value we can have it for the factor. So from 0 to 1, from 0 to 1, and from 0 to 1. This means that in the time of 0 we want to have this for the first, so next we want this for the second, and then we want this for the third index. Okay, so at the end of 1 we want, for example, have the starting rotation of the second face. As you can see, we have the same graph but shifted a little bit by what? So initially we can shift this by the seconds itself, so the index itself. So as you can see, we have the same amount of delay as the number of the index. So with the seconds subtracting the index itself, when I have 0 here, we have -1 here and -2, and because we need to set here the clamp, so a minimum value of 0 for all the values below 0 and a maximum value of 1 for all the values above 1, the result here will be 0 and 0. Next, if I have 0.5 minus 0 is equal to 0.5, so we have the animation of the first phase, but here we have minus 0.5 because 0.5 minus 1, okay, minus 1 is negative, so the result is always here, 0. Okay, we don't have any animation, and the same for this phase. Here in the first second we have 1 minus 0 is equal to 1, so the end of the factor for the first phase. 1 minus 1 for the second, so we have the initial, the start of the animation for the second phase, and 0 for the third, and so on. Here we have 1.5. 1.5 minus 0 is equal to 1.5, but because we clamped this value to 1, we always have 1, so this end animation for the first phase. For the second phase, we have 1.5 minus 1 is equal to 0.5. So we are in the middle of the animation for the second phase, and so on for all the other phases. And now if I link this to this factor and go to the first frame, you can see if I press play, we have 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. And if we want to increase the speed, we need to multiply the seconds by a value or decrease. So if I want to increase the speed, I need to increase this multiplication, or decrease if I want to go lower. So 2, for example, and press play, and you can see in the half of a second I have the rotation of each face. And if I want to distribute, so to have a less shifting here from one face to another face, so to have an overlapped animation, we need to shift by not the E island index itself, so an entire number of index, but a smaller number. So we can take this island and multiply this island by a value like, for example, 0.5 if we want to have an exact middle overlapping between these faces. So like this, if I go here, you can see if I am in the middle of the rotation of the first phase, I will have the exact starting of the second, and at the end of the first phase I will have the starting of the third, and so on. And in this way I can have this animation. And it's obvious, if I don't clamp this, I have these results. Why? Because I enable with this menu the face orientation to see the top side and the bottom side of the face. And inside our group node, you can see the definition of the factor is from a minimum of 0 and 1, but interactively. So you could pass a value higher than 1 or below 0 if you want. And I decided to not clamp this value inside this group node because with the rotation you can use the degrees if you want to use specifically the degrees. But if you want to use a simple value like 1 round, 2 rounds, etc., 1 round to have the rotation from A to B, okay, so the amount of angle rotation is 1 round, 1 factor, and you want to use a multiple of this angle rotation, you can use this factor but with a multiple value, as you can see in this case. So this is the same behavior of the free rotation, but not using the rotation in degrees, but using multiple time the factor range. Another example is using a curve line, for example, and this is very useful because you can add inside your geometry curve, link this to the final output of the group, and continue to use the vertex group to have references from the mesh of your object and use those references to manipulate curves inside your geometry nodes. So for example, if I take the original normal got from our geometry, input geometry, I can use this curve line and link these, and as you can see we have a new curve, and link this curve to rotate it through a particular direction. So if I want to go from the same normal direction to the negative y direction, you can see I have a curve and not vertices, but I'm still rotate the control points of the curve from the normal of the original face of the mesh inside this object to the negative direction of the y, okay, and all works. And you can do stuff like this. So for example, I have a curve line, I resample this curve like this 12 times. Next I'm going to set the spline type not poly but Bezier, and set the handle type to auto to have a smooth curve. And for example, I want to start from the negative direction, so this is my line with these 12 points. Now I want to rotate these from the same vector, so a positive x and a positive z-axis, so this direction, okay, from this direction to the direction of the y, so a negative direction of the y, okay, like this, but starting from this point, so the starting from a negative x. And if I do this, you can see the correct rotation of this vector in the correct way. But if I want to do a similar way using the scene, I can delay this operation, subtracting also in this case the index of each point, multiplying it by a value and multiplying the seconds to increase or decrease the speed of the animation, like this. And if I link this to the factor, clamping the value, you can see this particular effect. So I go here and press play, and as you can see this animation, instead of using the scene seconds, I can use a simple value, so I can manipulate this manually, and as you can see this is the final result. And if I uncheck this clamp, you can see the continuum rotation but delayed for all these control points, because I'm using multiple times these factor values, so from 0 to 1, and then from 1 to 2, and 2 to 3, and so on. And maybe you want to randomize the final target for all the control points instead of using a single -y direction. So for example, I can take these two and link to a random value between -1 for all these axes, and in this way, as you can see, we can have a rotation of all these points in the 3D space. And you need to keep in mind that if I link here the scene and specifically the seconds, for example, and press play, you can imagine that all the control points stay in a different altitude, an atmosphere like the Earth, and continuously go around its random orbit around the center point of the rotation, like this. So keep track of this point, and to do this we can instance on point something, and we can join these together and add a sphere like this, link the mesh in the instance, and go down with the radius and select only the end point selection, because we want only the end control point like this. Okay, this is the sphere, and if I press play, you can see this sphere is rotating around this point along a random rotation and on the same plane of rotation, this plane of rotation, and it has its orbit. Another example, I make a cone and scale like this, and I move this a little bit here. Then I'm going to make another cone, go in edit mode, and I will select all these vertices and merge them at the center to have only two vertices. Now I'm going to take this cone, edit mode, select these, and I will go in the Vertex Group and set these as the center rotation and assign all these vertices in the Vertex Group center rotation, because I want the center of this group of vertices as the pivot for the rotation of the entire cone. This is why I use the Vertex Group technique. And inside the cone, I want to create a new geometry node, and I want to add the rotate to group node like this. And in this case, I want to take the second cone and drag inside my workflow, and what I want is to sample the position of the first vertex and the second vertex to make a direction. So as before, I can select the vector, I can add the position of this object, duplicate to take the position of the same geometry but at the index 1, subtract one and the other to get the direction. I don't know if it is from here to here or from here to here, I don't care, and link these to the 2 direction, and from we can choose the Z direction, for example. And for the center, I want to use the center vertex group as the center rotation. Now if I increase the factor, what you have here is a very bad result. Okay, why you have this very bad result? Because you have a wrong scale. So remember always Ctrl A to apply the scale, otherwise the rotation will be very ugly. And now, as you can see, the correct rotation starting from the center I want to use for the pivot. If I want, I can swap the subtraction to have the opposite direction. So if I increase the factor, as you can see, the cone stays as is, because the direction now is starting from this point to this point. So I can pin these geometry nodes, take this object, go in edit mode, and move in whatever space I need this vertex. The cone will follow always this direction. And remember always this situation: if you have the rotation on the target geometry like this, so 90 degrees on the X, you can see the wrong direction of the cone, because the cone doesn't know what is the rotation applied to the object. So in that case, you can use the the relative selection in the object info of the target object, because in this way the object can recalculate and evaluate in a correct way the actual rotation and position of the target object. And in this way I can move the vertex and move the axis where I want, and the cone will follow the same direction of the vertices. Another example is this. So I re-enable the geometry to instances inside our workflow. I check the as instances like this, and imagine you want to rotate from the x to the y axis, so a positive x like this to a negative y axis, but I want to make a delayed animation and looped animation like this. So I can take the seconds and subtract like before the number of the index of the instances, but multiplied by a little value to overlap the animation, and using the multiply in the seconds to increase the speed of the animation and link this to the factor. If I do this and clamp the value, you can see this delayed animation. So the plane is the first and the curve, the profiled curve, is the second object. But if I don't clamp this and make the sign of this value and I multiply and add the result like this, I have this delayed animation. And if I want to increase the delay, I can increase this, and you can see the curve is starting to rotate in a waveable way. Why? Because I'm taking this subtract output, I make a sine function, but because the sine is a function between -1 and 1, and I want to have a factor here between 0 and 1, so like this, because I want a minimum value of 0 and 1, what I need is to add 0.5, this half of the value, to shift all up. But if I shift all these, you can see the range we have here goes from 0 and 2, but because we want to have a maximum of value of 1, I need to divide this by 2 or multiply these values by 0.5 to have the half of the amplitude. And this is why I used this multiply add mathematical function to multiply the input by 0.5 to have the half amplitude, and then append 0.5 to move this range from -0.5 and 0.5, because I take this and multiply this by 0.5, and shift this, adding 0.5 that is equal to 1 and 0.5 that is equal to 0, so to change the range of the final values. And this is the result. Not bad. Now I take this cone and grab here, and as you can see we have the ability to add the modifier rotate to directly in the stack modifier. And if I go in the layout like this and go in the modifier stack, I can rotate all the object from the z-axis to the x-axis, for example, and increasing the factor, you can see the result. And you can duplicate this rotation and add other rotation, so another time from the z-axis to the x-axis, so I have another rotation of 90 degrees. Or if you want to rotate from the x-axis to the y-axis, and if I increase this, I have this, and I can control this influence and the influence of the first rotation as I need. And that's it. Always thank you guys for watching this video. I hope you learned something, and I hope you will find this tutorial very useful for your project. Always you can find this project in my Gumroad page. If you like what I'm doing, please subscribe to my channel, check a like, leave a comment, and see you to the next tutorial. Bye!